Hi everyone, David Maley here, and today we're going to do part 5, the final part for this series that we have on multiple logistic regression. So in the past video, number 4, we already determined what our models, we built the models, right? And in parts 3, 2, and 1, we went through and did some exploratory data analysis with it. We went and created our test and training sets. And then we did some more testing with that. But in this one, we've already built our models. We've actually built 2. One with the predictors that are important only, and then the other one with all of the predictors in it. And we compared them both. So we're going to compare them again in this one. Let me show you. So we're going to start off with the first thing is have ggplot2. Okay, because we're going to use that for some of our graphing and stuff here. So that's this right here. Okay. Next, and that's just a library you're going to load in, and you may have already done it before, that's fine. Next what we're going to do is we're going to use ggplot right here, this code right here, because we're going to plot, remember we got our type or day type, and it can be an A or a B, right? B, higher sales, A, lower sales, B, higher crime, A, lower crime. We already figured that out based on Kratom sales, Kratom product sales, with our data set. So we already figured that in the earlier videos. So what we're going to do right here is we're going to plot them, right? So let's do that first. So let's run that. And this is the plot. So the plot shows, obviously, of our data points, they're either A or B days. There are no C, D, or anything other days. And then when we look at this, we have a little bit of overlap at about the 250 level of violent crime, right? If you look right here, a little bit of overlap. But you can clearly tell there's a big difference between a B day and an A day. There's a lot more values down here and a lot more values up here. So this is one way to look at it, but let's look at it another way. Let's do the same in a bar graph, right? So first, before I do that though, let me just make sure you have the code here. It's all highlighted right here. Test data 1, that's our original data set, okay? Violent crime, day type. So remember, when we're done with this, we want to squirt back to that original data set. We're going to do that down below. So we want to look at this, not the test data set or the training data set for this one, okay? And the same, now the difference is, now I want to look at the plot of this. And we're going to look at our training set now. But we could use any of them, it doesn't matter. But let's do this. This one is the par mfro. All that does is set it's one graph. If I were to make that 2 by 2, think about it, 2 graphs by 2 graphs would be 4 by 4, right? Or no, that'd be 4 total graphs, 2 by 2. If I put that 3, 3, I could have 9 graphs in there. Okay, I only need 1 for this, so let's do this. And this backs that up also. Okay, so we have that one, and we have this one, which shows clearly the day type A and B, right? So we have that. Now also, we could have changed this instead of training data. What if we did test data 1? Let's just do that. Because remember, test data 1 is our full original data set, right? So let's do that instead. Look at that, same exact thing. So that's what you want to do, is you want to look at the original and the test and the training. If I wanted to look at the training data set, it'd be training data. So I could take that and make that training data just like that, or auto correct it in there. And look, they're all basically the same. So what that tells you is that you have a clear difference between type A days and type B days, right? So next, what we want to do is we want to go into the analysis of variance. So analysis of variance is going to either back up our earlier findings, or it's going to say, no, they're wrong. So it's done with this right here, ANOVA, or analysis of variance, and your logistic model, and then the test. In this case, we're using chi-square. And so we're going to do it twice. We're going to do it with the logistic model, and then I've got logistic model 1, which is the original one without any of the lower importance or 0 importance or negative importance predictors removed. So first, let's do this one. And what we find here is this is the analysis of variance, the output of it. Let's bring this up so you can see a little bit better. You might get some warnings down below. Don't worry about those. This is mainly what you want to look at. So you want to look at your p-values and the stars next to them. And they'll tell you here, if there's a dot, that's not as important as a star. Obviously, a star is not important as 2 stars or 3 stars. And then the lowest is a 1. So if you look at this, or the lowest is space actually, and or the worst value of those. So when you look at this, you clearly see this backs up that total sales and violent crime, which we already listed before, or really figured out and deduced that, are our best values here. Then they're followed by average T. Remember, we said that also about temperature and units. So we utilize, those are all utilized in our model, right, in our logistic model. Now, if we look at the other one and we compare the two, let's take this. That's ANOVA. Now, instead of just using our logistic model, we've added logistic model 1, which is the one without anything removed, and our logistic model and this. So let's run that. And what we get is this. This is a comparison now of 2 models instead of a comparison of the fields or the predictors, right? So when you look at this, clearly you see model number 2, which is this, right? Logistic model is the better value of the 2. Okay, but there's not a huge difference between them, so there's not a lot of values in here. And the reason being is that they're pretty close. They're both. We have such a high accuracy with our model that even the one with the bad values is still very accurate, still very high. It's just not as accurate as the other one. So now that we've done that, you can see here the notes I put up here. So it backs up our earlier findings with total sales and violent crime, that there's significant predictor values. Let's open this up so you can see this. And it also shows that the difference is not that large between them, as I said. So next what you want to do is you want to go to the summary. Summary is this very simple function to run. Summary of your logistic model, right? But there's a lot of important values here and interpretations of this. So let's look at this. In this, somewhere here, there it is. There's our AIC of 14. That is a very low value. Remember, we told you earlier you want to be below 100. So we're definitely below 100, so it's a very strong value there, so I put right here, right? Good low AIC. Next, what we want to do is we're going to look at the null and residual difference, or deviance. So right here is your null, and here's your residual, right? So these are the 2 values right here. And what you want to see is a difference between this number, which is the null value, and this number. So basically, if the larger the difference between the 2, the stronger your model fit. The closer they are, the weaker your model fit. In this case, you have a to the negative 0.9 and a plus 0.1 here. What that means, you have a tremendously huge difference between these 2. So that indicates a very strong model fit. Next, let's look at our p-values. Our p-values, oh, they're not optimal. Optimal would be, remember, 0.05 or below. We have high p-values between 0.999 and 1. So that doesn't tell you that we're bad here with a model fit. No, on the other hand, it just tells you that there's not a predictor that really stands out from the others as being the strongest of them all and being super significant in itself. Instead, they're significant together. So that's what this is telling you here, and that's fine. Then, so we've done that with the high p-values. Now, we want to interpret this. What is the actual saying here of this summary? What is this actually telling us? Well, each increase in per unit of, let's pick one, total sales here, right? This one right here. Each increase of that, what it will do is it'll have a minimal effect because it's a very small number, right? See, look at this. 2.058 times 10 to the negative 0.2. So what that means is you would think that it's very insignificant, but keep in mind, and that's why I put my notes here so you can see. Let me open this up so you can see them. So the difference here is that we are actually dealing with sales, right? And we're dealing with between $400 and $5,000 per week, right? So a dollar change will have 0 effect. That makes common sense. It'll have very small effect. But a $200 or $800 change will have a huge effect. So the difference here is you have to look at it from that perspective. A typical change that would have an effect would not be $1. Okay, so a change of $200 or 200 units would make a significant impact, and that's why that you have to keep in mind, remember the numbers you're dealing with, and remember common sense fits in here and perspective. Okay, so what we're talking about here is this total sales has a big impact with normal changes, so like a $200 change, a $300 change, or uptick or downtick in sales. Same with violent crime. Okay, one crime committed in a city of a population of 800,000 is not going to make a huge difference in their numbers, their crime numbers. 300 murders in a city makes a huge difference. Very negative stuff. Okay, in that case. So we've done this summary, right? And that's what this is. And we just explained to you what the estimates are, and you can pick different fields. So this would be your value of the change of one unit of average temperature, or whatever it is you want to look at here, violent crime or whatever, based back on the original variable that you were looking at, which was what? It was day type, right? So next, we've already shown you those things which point to that we have a very high accuracy model here, right? Now what we want to do is we want to predict and determine and then visualize the probability of an A or B day, right? Do we have more A days or B days, right? So this is just another way of looking at the data we showed earlier, which is, remember earlier before I run this, let me bring this back out, we were looking at it with this, right? And you can clearly see there's a type A day and a type B day, and they're very different. They have different levels of violent crime, different distributions of it, and you know, the type A day has a lot less crime, the type B day has a lot more crime. You could also do this with total sales and other pieces of it. I'm just showing you with that. So now we're going to take the same code and a little bit different, we're going to do a histogram of the probability of an A or B day. So we're going to show you, instead of just looking at that, what is the chances of us having an A or B day? Are there more A days or more B days? So let's run that. And let's bring that out so you can see. That's what we showed when we first started this video right here. So you obviously have a little bit more chance of a B day than an A day. Okay? And that's how that works. So now if we bring this up, let me show you, there's the code. Okay, hist, logistic model of fitted values, right? There we go. And your main is histogram, and then it's a very simple piece of code. Your X label and your color. That's all. I could change this to something else if I wanted to, and that's how you get this graph over here, which is a little bit nicer to show, you know, your boss or somebody what your probability of an A or a B day or a high or low sales day or something like that. So next, let's get into some cool stuff. These are some cool data science things called the confusion matrix. Okay, and the confusion matrix is just another way to show you how accurate you really are. It's not a graph like this, it's a table. So what we're going to do is we're going to take this code right here, and what we're going to do is use the 0.5%, is it B or A, and then remember we did the same thing, we're looking at this logistic model dot fitted values, or $, which is your data frame, fitted dot values, and we're going to put that in predict. We want to know, are we A or are we B? And then we're going to take that and we're going to put it into a table, and we're using what? We're using the training data. See that, how that works right there? And then we've got row names, right? So we want to have your row names and your column names, right? So we're going to have observed versus predicted. See that? Observed versus predicted. And then that'll go into my table 1. Okay, so let's run that all together. We run that, and there's our table. So now that table, you're looking at it and saying, oh, it's down here. We're not looking over here now. We're looking right over here. So you're looking at the top is predicted, the bottom is observed, right? To the left, whatever. So what you do is you take these observed values straight across. That's the observed, right? Observe what you really saw. And then your predictors, you go straight down, right? So you'd have 21 and 22. And what you find is they're the same. So 21, 21, 22, 22. What that means is you have 100% accuracy here, that every predicted value matches every observed value. That's very good. So then let's do this one. We take the same thing of our table, and we get the efficiency of it. And that's not going to show anything yet, but then we just hit efficiency, and efficiency of 1. What does 1 mean in percentage? 100%. That means we're 100% accurate with what we have here. Yes, you can go back through this, and it's just the sum of my table 1 versus the sum of diag my table 1. That's all you got to do. Okay, efficiency. DIAG, my table 1, divided by the sum of my table 1 gives you your efficiency. So next, we've determined already that we have a very, very highly accurate model. So let's go and do the final step. What we're going to do is we're going to predict our logistic model and score the values back to our original data set. Remember, the original data set is called test data 1. We're not using test data. We're not using training data now. All right, so you use this piece of code right here, which is the predict function on our logistic model of the test data 1 data set with link. That's what we do, and it goes into this new data frame called pred. And then what we're going to do is we want to show the head of it, and let's see what that shows. Those are our values. Now that may not mean much to you, right? It's -87, -107, plus 143. Okay, but what you're going to want to see here is not that. What we want to see here is this piece right here. So watch this. We're going to now take that. See how pred is right here in here? Right there. If else pred greater than 0, B else A. So the negative ones here that were A's and the positive ones were B's. Okay, that's how this worked out. That's how that figures that out. And then what it's doing is it's taking that and saying, okay, I'm going to put that into a new column called class in the original data set. Why would we want that? Because we already have day type in there, right? So if we have class, we can go and visually look at day type and class and determine, are they the same or are they wrong, right? Even though everything above this, all the tests said we're at 100% accuracy, we're going to be very accurate, everything's going to match up. Let's go and take a look. So first, let's do this, right? We did that, so we've got B and A's in there in this new data frame. We haven't looked at it yet, but we've got it in there, right? There's no errors or anything. Now, let's take a look at, remember, what's the head and the tail? Top 6, bottom 6. Let's just look at that data. We could look at the whole thing if we wanted to, but let's just look at that. Here's the head, right? It's not pretty. It's an R. Let's just open this up so you can see the whole thing. Well, it's going to fill it right there anyway. But regardless, this is what you want to see right here. See this down at the bottom? Day type and class. They're next to each other, and look at the match. AA, BB, AA, BB. 100% match. Okay, that's just the head. Let's look at the tail, the bottom 6, right? Boom, BB, AA, BB, BB, BB. 100% match. So this matches up with what we saw earlier. We have gone through an entire data science project here that we actually use in data science to show, you know, are we going to have a good sales day or a bad sales day based on internal and external sales. So here you saw through these 5 videos how to do that piece by piece, from exploratory data analysis and loading in the data set to determining the predictor values, to getting the model value, to doing testing and more testing, and to make sure that at the end we end up with an extremely accurate model, and it's fully documented with multiple graphs, multiple histograms and other proofs, confusion matrix, all these things that back up the ANOVA and everything that back up our findings and say, look, this is a very accurate model. We now have a model, this logistic regression model, that we can utilize now for this set, obviously, but also we'll be able to use it on other similar data sets. So we've built something really cool here, and this proves beyond a shadow of a point that we're very, very accurate with this. I hope you found this interesting and entertaining and helpful, and this will help you to figure things out. I mean, this is actually really mind-boggling stuff, because what you just went through here, we can now determine if a company's going to have good sales days or bad sales days. And remember, we brought in the internal sales data, right? So we've got sales and transactions and units and stuff like that. But we also have externals, right? We had the average temperature, we had violent crime, Okay, you could have brought in other things. We could have brought in nonviolent crime. We could have brought in wind. We could have brought in, who knows? It depends. And then when you ran the predictors, the importance of the predictors, and we did that with the random forest and the Bruto method, you can determine, well, which ones should you use and which ones shouldn't you use. Okay, this is a really interesting full data science project, and I, as a data scientist, do use this. Maybe not every day, but I use this same process probably about once a month for different data and stuff that we do to show, you know, what kind of sales day some stores are going to have, what kind of sales day, or what kind of, it could be anything. So thank you for watching. I hope you found this helpful. Please take a moment to subscribe. Make sure you click that bell, because that means you'll be notified of every new video I put out. If you don't click that bell, you will not get notified of every new video I put out. You'll just get notified sometimes. YouTube does that. So just go and click the bell, subscribe, click the bell. Please like and share, and have a great day. Thanks.